In this video, we will build an isometric tile map. Let's start by creating a new 2D project in Unity. The project we're building is called Moon Mist Hollow. Let's name the scene World. This will be the world map of our game. We will save the scene in the scenes directory of our project. We can see our new scene in here, and we can delete this sample scene. We need to load in our assets. I purchased two very nice collections from the asset store, and we've linked them both in the description for this video. We have all the images we need in a resources directory on the desktop. We can copy this directly into our assets directory, and when we return to Unity, it will automatically import the assets into our project. I'll open the directory for our project in another tab and then just copy over the resources directly into the assets directory. Now if we return the focus to Unity, it will automatically import these assets. Here we can see all the images in Unity for the first time. We now need to make sure that Unity is displaying sprites using their pivot point rather than their center point. My editor is already using the pivot point, but this defaults to center. This is important because the stacking of the tiles for an isometric map relies on this pivot point. So we want to be able to see it. Next, we will change the pivot point for our images. The pivot is the origin of the image. It is the point which defines the position of the image. It will affect how the image is layered in our tile map to create the illusion of depth. To change the pivots, we can select a group of images and then change the pivot for the entire group with the inspector. We first change the pivot option to the custom setting, and then we adjust the pivot position. For the character, we want the pivot to be right at the center of their feet. This way the character's feet will be considered the position of the character, and this will make the collisions work nicely. Let's drag the E01 image into the scene so that we can see the pivot point. The blue circle in the center of the image is the pivot point. With these images, a Y value of 0.12 will work. We can leave the X value in the center at 0.5, and we can apply this to the entire group of sprites. When we select the sprite again, we can see that the pivot has moved to the feet of the character. Now we'll apply this same pivot to the left, right, and up images for the character. Don't do the tiles yet, they will be done slightly differently. Now that all the character images are done, we can change the pivot points for the tiles. But they are drawn so that the pivot should be near the top of the image. As before, the first thing we do is change the pivot from center to custom. We can select all the images in the tiles directory, change the pivot to custom, and then change the Y value to 0.78. We can apply this setting and then drag the brick A image onto the scene. When we look at it closely, we can see that this centers the pivot around the top of the brick. Now let's set up a tile palette to use when we build our map. We need to open the tile palette window. It's under the 2D section. Mine is already open because I like to keep it docked to the right of the project console window, but you can move it around anywhere you like. We also need to do one more thing to make sure that our tiles display correctly. We need to update the pixels per unit for our tile sprites. We want a tile to be exactly 1 unit long on our tile map. So since these tiles have a size of 128 pixels, that means we want to set 128 pixels to equal 1 unity unit. We also want to do the same thing for our character sprites, but it's a different size, so we'll use a different pixels per unit. You can also see it doesn't have to be exactly equal to the width of the image. To a certain extent, we're trying to ignore some of the transparency on the side of this image. We'll be sure to do all 4 directions for the characters' images. We can now choose Create New Palette from the drop-down on the Tile Palette window. We will call it World Palette and set the grid option to Isometric Z as Y. When we create it, it will ask us where to save the new tile palette. We can go into our Assets directory for our project, and we can create a Tiles directory inside. We can then save the new tile palette into this directory. We'll come back to our new tile palette in a moment, but let's get our tile map created. We'll go to the object hierarchy and we'll create an isometric Z as Y tile map. The Z as Y part means that we will be able to sort tiles at the same Y position based on their Z values. This will allow a stacking effect that creates the illusion of tall tiles that the characters can walk behind. All tile maps require a grid to place the tiles on, so the grid was created automatically for us. There's one global setting we need to update so that the sorting of our tiles works correctly. Under the Edit menu, we go to Project Settings, and then make sure we are on the Graphics section. We're going to set the Transparency Sort mode to Custom Axis. And then we're going to change the sort axis to the y-axis. Because we're using the Z as Y isometric tile map, we also need to add some bias towards the Z value as well. Unity currently suggests minus 0.26. We don't want it large enough to override the y-axis sorting, but we do want it taken into account. We also need to change the mode of the tilemap renderer to individual. The chunk rendering would break the tile sorting we just set up. When chunk is activated as the mode, the tiles are put into batches and rendered together instead of layering them along the y-axis like we want them to be. Let's put the tiles onto our tile palette and actually begin painting some of our tile map. When we move the images onto the tile palette, it'll ask us where to create the tile objects. We can now choose a brush and one of these tiles and begin painting onto the map. We will choose the grass tile in the center, and then we'll select the brush that is called Paint a Filled Box with Active. This lets us fill a large rectangular area with our tile selection. Alright, let's save our project and then run the game for the first time and see how it looks. We can also use the paintbrush tool to create an outline and then fill it in with the bucket tool. We'll use this to create a river in our scene. We'll play the game one more time to see how it's changed the scene. In the next video, we'll be adding buildings and structures to the map.